Right, now I'm pretty sure you've seen these things. These are whirlybirds, or roof turbines, or roof turbine vents. And you see them absolutely everywhere. Now they operate in one of two ways. The first way is the wind will blow them around, but they're not particularly aerodynamic, so it's not particularly efficient. Another way that they work is the hot air in your attic is forced to rise up through them, sucking in cold air through the soffits, and it rotates the vent. Now it'll do it summer or winter. It does it in the summer because basically the sun bakes your roof and your attic gets blisteringly hot, and then the Whirlybird helps bring in the fresh air and keep the house cool, because you can obviously get the house hotter than the outside. In the winter you've got your heating on, and it's inevitable that that heat is going to rise into the roof space, and then it goes out through the Whirlybird and sucks in cold air from the outside. So in a degree it's both capturing the wind and scavenging the energy from the hot air escaping through your house, which you want to happen in the summer, and in the winter it's just going to happen anyway, so you're going to lose that air. Now, a lot of people have asked me about these, and can these be turned into generators? Well, the answer is yes. Because the problem with this thing, obviously, is it's going to turn, but obviously not like super fast. I mean fast, but not super fast. And the torque on the shaft is going to be really, really low. So you can't just bolt a motor onto it. There are three things that affect generation: the amount of wire that's going through the magnetic field, the strength of the magnetic field, and the speed at which it travels. Now, at the centre of a whirlybird, it's not travelling particularly quickly, but of course they have a huge diameter. So at the edge, it's travelling much, much more quickly. So it could be good to take advantage of that. So we don't have much torque, which is why we can't put a motor on the centre, but we do have quite a lot of speed because it's got a big diameter. So I think the way to take advantage of that is to make lots of little coils and put them around the edge. Of this, obviously, is to basically attach them somewhere on there. Go around, fit the magnets in, and we're going to have ourselves an axial generator. Now, the Aussies are very keen on this sort of stuff, and they improve the efficiency of this by adding this thing. So it's a fan blade. Now, fan blades obviously are pitched to force the air in one direction, and in this case it's in that direction. So they've fitted a fan blade to it, forcing the air up, spinning around, forcing it out, and they reckon they've got a 40% increase in the efficiency. Now, the other thing, of course, is that this is actually itself a flywheel. I mean, there's mass here. This thing weighs a few kilos. So when this gets spinning, it stays spinning because it's a flywheel. I want to use that flywheel effect, which is why I haven't put metal cores in here. Now, I was really interested in that output from the lack of metal core. You could put a metal core in if you want, but of course you've got a magnet next to a metal, you're going to have cogging, and that's going to have to be overcome. So I decided that there was plus and minuses to all things, and I'd leave out the metal core. And given that we're getting actually a reasonable output from that, I'm quite okay with that. That's what I'm going to do. Okay, so I've taken the thing to pieces, actually, and inside there is a circular drum with four quite thin stairs holding that drum apart. And on the rotating bit of it, there we go. This time we've got 5 stairs and a free to rotate. This is actually stainless steel, non-magnetic stainless steel. So I have to make a generator ring that I think is going to be strong enough to take all the forces that are going to be on it. Then I'm going to make that ring out of this stuff. Now, this is sold here in the UK for UPVC trim. You can buy it in the US as Sintra board, but it's quite handy because this is 47mm thick, and it's the same size actually as the magnets, which is great. So what I have to do is turn this into a circle that's the same size as that. And what I've done is I've taken a piece of MDF, drawn a circle on it with my homemade compass, which I'm quite pleased about, drilled a load of holes and stuck some 4-inch nails through them. And what that means is I can take this stuff and with its own natural spring, put it into that jig, and it will spring out to form a circle. It won't be strong enough, I don't think, so I've got another piece that I'm going to put in there as an inner piece to help push everything into shape. So that'll be the circle. Now the good thing about this stuff here, this UPVC, is it's actually quite flexible and quite strong, but it glues with crazy glue stronger than the original material. So I'm going to glue that together and make a band out of it that will be the band that carries the coils, because this is going to be the fixed band. The rotating one's going to be inside that. So when you've done, what you get is this surprisingly lightweight yet rigid hoop that will hold its own circular shape, which is pretty cool. Now all we need to do is take all those coils that we made and glue them on to the inside. You put a bit of glue on, put a clamp on, and go all around the edge until you've put all the coils on. So once that's all dry, actually, it's quite safe to take it out of the jig, and there it is. Now you'll notice there's a ring around the top, and I've drilled that out and fed all the wires through, but there isn't one at the bottom. Now it needs 2 rings because this will have a tendency over time to spring out, and if we put a ring there, it'll help prevent that tendency. So to make that ring, all I've done is miter together 4 bits of builder's board or Sintra board, whatever you've got. I've mitered them together, glued the joints, and I'm going to cut them out so that it's the outer diameter to one side and the inner diameter to the other side using this cutting tool that we made in a previous video. Now I marked all of this up with that compass that we made in a previous video. So all you do with the cutting tool obviously is put it in this pre-prepared hole and slide it around until you've got to where it wants to be. So I'll cut those out and attach that. Okay, so after I'd put that ring on, all I did was drive some brass pins in the bottom, wind the core wires round and solder the whole thing to it. And that's the stator body. Now, when we put the rotor on, it does need something of a guide to help that keep that rotor true. So we need a block to go on the stator body. And I'm going to use this stuff again, this builder's board stroke Sintra. It's amazing stuff, actually. It glues with super glue, stronger than the original material, so it's lightweight, strong, and glues really easily. We're going to use our guide again to construct it. Here I've got 3 at 1 centimetre, 4 arms, and then a couple of twiddly bits to make it look pretty, and all I'm actually going to do is glue the whole thing together. So just place it on there and get gluing. 1 arm at every 45 degrees. So once you put those bits together, you'll have something like that. Now you can see I'm using my jig again. I've put an 8mm rod in the centre, so it's centred. This has got an 8mm hole in it, and that just feeds onto that rod. Line everything up and glue it down. Okay, and that's the stator finished. Obviously, it goes in there. That's a lovely fit. The other way around, incidentally, but that's where it goes. And if you're worried at all about this stuff, then this is the stuff you find in British homes all the time. It's what's used on the roofline, and gluing it with cyano acrylic glue is exactly how it's fixed. So this is weatherproof, extremely good bond, and shouldn't be fragile at all. But I guess we're going to find out. So I've taken my jig and I've measured in the thickness of the stator. Then I've measured a gap of about 2mm. Then I've measured the magnet, and then I've measured the thickness of the material that I've got and tested if this fits. And amazingly enough, it fits. I mean, that's just lucky, hey? So what I've done with the jig is put all those measurements down, drawn all the circles out, and then drilled a load of holes to take my 4-inch nails, and I put the 4-inch nails back in so that we have now our adjusted jig, and this time the jig is adjusted for the rotor. So here are the holes where we made the stator. Here's the holes where I was just babbling on about, so we can make the rotor, and the rotor is going to fit just inside that. So if I can get everything inside this circle, I'll be able to stick the magnets on and have the magnets clear the stator by about 2mm. I mean, maybe that's enough, maybe it's not enough. We're going to find out, because that's what I'm going to do. Now, to make that rotor body, the plan is, again, to use our marvellous, wonderful, fantastic Sintra board, builder's board. And it will spring round and fit in there really rather nicely. So it fits inside. Then we have an extra little gap, and I've got this stuff, which is a strip of ABS. And I'm going to put the ABS on the inside of that to make my hoop. Now, once I've made my hoop, fingers crossed, that will just fit. And if that just fits, what we're going to do is either glue or heat weld the edges of the blade to the ABS strip, and we're going to glue the ABS to the PVC. And I'm already testing a bit to see how strong that bond is, and that's a really strong bond. So that's what I'm going to do. Put all that together. Okay, and that's pretty much it. That's been heat welded onto there, and all I've got to do with this now really is put my magnets on. I'm going to do a north-south pattern. Anybody wants to do anything else, well, knock yourself out and let me know how you get on. Now this just fits on there like that, and with the magnets in it's ready to go. So let me stick the magnets on. Okay, so that's the rotor done. I got 50 magnets around it actually at the end, and I just glued them on and put some hot glue on it. Considerable care to the direction in which these coils were wound. I made sure that I knew where the start of it was, what the direction of the winding was, and where the end of it was. Then when I mounted them in here, I actually put a mark on each of the drill holes to tell me which one was the start of the coil, and made sure that every coil was in the right direction, so all the winding directions are known. So when I connect them up, I won't be connecting one with an opposite winding to cancel the coil out. I'll know all the winding directions. Oh, so my finger. Incidentally, this is like a knife edge in certain sections, a little bit rough, and it's also very heavy. So when I pick this up, I need to pay due care and attention, and sometimes I don't, and that's where that came from. It's quite a nasty cut, but it's just me really not paying enough attention. But hey, such is life. I suppose I could have worn gloves, but you know, if you're going to do stuff, you've got to accept that every now and then you're going to get a cut, and you just live with it. So I just super glued it together and lived with it. Another fantastic use for super glue. Super glue, incidentally, was invented by the Americans during the Vietnam War for surgery, so it's brilliant for gluing cuts together. I'm sure loads of people know that. Anyway, to this. What we've got here are the 5 stairs holding this, and this rod in the centre gets fixed to the base. So effectively that's fixed and this rotates. Now we can use that. We need to make sure that that's kept free, but we can attach to the stairs here as long as we leave that central rod free, and that's what we're going to do with the ring. So this ring here is going to be attached at points on this part of the ring to those stairs. This fan blade won't be attached. What we do to fix this in is, as I say, drill it out so that it's free to spin on that central axle, or equally the axle is free to spin through that, mark it up and fix it to the stairs. So that's what we're going to do. Okay, so that's my central ring attached. Now I've actually removed this once I get it attached so that you can see how it's attached, and you can see that all I've done is fasten the central ring onto the stairs using these angles, which is these things. That means that that bar is still free to rotate. So when we fix that bar to the base and the wind catches this, or the thermal updraft catches it, it will rotate, rotating the ring obviously. So what we need to do now is put that bit into the base, and we fix that bit to the base because this rotates relative to the base. So to fit this thing was a piece of cake because we made it the right size. All I did was remove those central stairs, put the ring in, and I removed the central boss because that central boss was just for that demonstration. Put the ring in and then fastened everything back together. Now the stairs did go at the top here, so where those stairs went, there we go, I just found some very short screws and screwed those into where the stairs were, otherwise it gets even flimsier. So the whole thing has now been screwed to this plastic ring, but the stairs have been moved, and you can see here we've got a couple of drill holes where I remarked it, and the stairs will actually go in there. As luck would have it, that central bar will actually reach through the ring and reach the new position of the stairs, which is great. So all I have to do now really is slot these two bits together, bolt the stairs back in. Okay, so there it is all back together. There's the coils ring, there's the magnets ring. That actually I did have to extend. I sawed the bar off and used a 12mm extension bolt and then put some 12mm bar in it. It's no surprise, I mean, I did drop the stairs, so I had to extend that. So I really only got one job to do, and that is wire the coils together and then I get it in position and see if the thing will spin and see if it will generate. Set up to read volts, and I can tell you it's spinning quite well even in the lightest of breezes. I mean, it's actually turning a lot slower than it looks probably, because there's just not enough wind to do very much, but it is actually moving that. Now I've got these wired in parallel actually. Okay, well, to be honest, actually, I think that was really kind of impressive. I mean, I did wire it in parallel, so we got more amps than we got volts. The volts was sort of like 2 to 3 volts, something around about there, but we were getting a good 2 or 3 amps out of that. So that's a good, what, somewhere between 6 and 9 watts, I suppose. Now, we really didn't have a particularly strong breeze, but it had no trouble turning. If you're looking at something where it's a complete thing and you just want to turn that into a generator, the answer is yes, you can do it, and actually it does quite well, even in the lightest of breezes, as long as you go along the circumference of it. Anyway, I hope you enjoyed the video series, and thank you very much for watching.